Today, I'm really happy to introduce three colleagues from around the world. We have a US leader, a leader from Europe, and a leader from Africa who are going to share their thoughts on the challenges and the opportunities in HPC. And I'm also going to ask them a little bit about AI workloads on those HPC systems and even their thoughts on all the new hype and real announcements in quantum computing. So with that, please bring online here Dr. Sadaf Alam, Dr. Happy Sitole, and Dr. Dan Stanzia. Are you all online? There we go. We're pinning your feeds. There we go. Thanks for joining us, guys. Good to see you. Well, Dan, I guess I saw you about a week ago, but good to see you, Happy and Sadaf. All right, Sadaf, can I hear from you just to make sure the mic's working?
Hi, yeah. Thanks for inviting me. Good to be here. Happy New Year to everyone.
Great. All right. And Happy, you can unmute and come online whenever you wish as well.
Can you hear me now, Jay?
I can hear you, Happy.
Okay.
Good to see you.
Hopefully you can see me also.
Happy New Year to all of you too. So I'm going to ask you just to give a real quick opening intro of yourselves and of the center you work for. And please try to keep it to about a minute because I have a lot of questions to ask you. And we have a lot of attendees that want to hear from you today. So maybe a real quick intro. And I'm going to go around in the order of the windows pinned on my screen. So Dan, why don't we start with you?
Yep. Hi, Jay. Thanks very much for having us today. I'm Happy, Sadaf. Great to see you guys. I'm Dan Stanzione. I'm here at the University of Texas at Austin, where I run the Texas Advanced Computing Center that I took over from Jay a long time ago now, 11 plus years ago. So I've been here 16 years at TAC now. So having run some smaller HPC centers before that, TAC is sort of the National Science Foundation largest center in the US at this point. We were just named the new leadership class facility. So we're building out some new systems and expanding both our personnel and our computing and our cloud footprint moving forward, mostly for the open science community. And I'll just stop there because I'm looking at the names online and lots of you should already know about TAC. So.
Sadaf?
Hi, I'm Sadaf Alam. I joined Bristol about 2 years ago. I've been with this community for a very long time. Some colleagues said Sadaf and I know each other for unspecified number of years. Before that, I was at the Swiss National Supercomputing Center, and before that, Oak Ridge, and studied in Edinburgh. So at Bristol, we have a rather unique opportunity. We have been asked by the UK government to build this Isambard AI, a supercomputing system for AI. But the exciting part was that we are asked to build it in like less than a year, starting without a data center, without a team. So that's something kind of exciting, and I think it fits well in terms of how to turn things around for research computing so quickly. What are the opportunities if someone like us is asked to do something similar? But it really still builds on the background of doing things. So in Switzerland, I've been involved in several projects for GPU computing. So it's National Supercomputing Center was one of the centers introducing GPU for scientific computing for like 13, 14 years ago when it was not really cool. And then for weather and climate, operational weather and climate system. So I'm really like, as Jay said, for me, this is about the community. And I think I have learned and gained a lot by being part of the community. So I'm really, really happy that Google has started this initiative and keep it fresh and up to date. So I'll stop here and maybe hand over to Happy.
All right. Thanks, Sadaf. Happy.
No, thank you, Jay. And I think it's evening in South Africa. I guess it's morning in the US. And yeah, but I'm happy for the invitation to be part of this group. My name is Happy Sitole, and I am in South Africa. And I am at the National Integrated Cyber Infrastructure. This is an entity that basically brings computing, networking, storage together, so that provides cyber infrastructure for the whole of the research community in South Africa, but also we extend these services to the rest of the continent. So through this, one of the things that we really have to make sure is with limited budget, ensure that the researchers can have state-of-the-art technologies. And for that, we're looking at various partnerships. I worked with Dan for quite a long time, looking at how we can be able to provision high-performance computing facilities in Africa, and came up with some novel ways. So really looking at this community, like Saraf says, it is a community that helps us to always be innovative, look at how do we overcome the challenges in terms of providing the facilities. So I'm really happy to be in this space, because besides high performance computing, we are also the thought leaders looking at what are the other applications that are coming. And obviously AI becomes a big topic, not just for the research community, but also for governments and also for our industry. So I'm really happy to participate in this, Jay, and wish you all the best, yourself and Bill, in putting together this community.
Well, thank you all for joining. And I'm sure our audience is eager to get to these global perspectives. I'm going to ask one softball question first to emphasize the global nature of this. How many languages do each of you speak? And Dan, I'm not talking about C and Python here.
Yeah, it pretty much limits me to one.
I know the answer for Happy, which is I'm going to save him for last. Sadaf, how many do you speak? Yeah, and Happy, I know you're going to win on this because you and I had a great conversation about this once. How many languages do you speak in dialects?
In South Africa, we've got 11 official languages, but then there's a 12th one, which is the sign language. So if I look at all the 12 languages, I can at least comfortably speak 9 out of them. The other 2, I can hear and I can have little communication. That's not bad. Sign language, I'm not yet that quick. So 9, I'm comfortable.
Well, Happy, I think you've clearly got something to work on in 2025. Clearly, you have to learn 3 more languages comfortably. All right, so let's get to the.
Sorry, no, I said I would like to claim also that maybe I speak more languages that across continents. Maybe not in terms of count, but across continents. Yeah, no, that's
all right. Let's get. I've sent the questions that I'm considering asking today to all of you in advance, because we know we want to give very concise answers to get to as many of them as possible in this session. I'm going to start with the obvious first question. Like each of you to give me, what is your top challenge you see facing HPC today? The second follow-up question is going to be the under-recognized question. So if you want to under-recognized challenge. So if you want to combine those in your answer, that's fine too. Dan, let's start with you again. What do you see as the top overall challenge? And maybe what do you see as an unrecognized challenge that you want everybody on this call to be aware of?
Yeah, okay. Well, I think the top challenge is going to relate to a question you're going to ask a little later, but when you say what's the top challenge for AI, but I think for HPC, it's embracing all the opportunities that AI presents without actually getting replaced by it. Somewhere down the line, I think there's enormous pressures on our staffs, to step out into AI related things. There's enormous financial pressures that are a result of it that are driving up our costs dramatically in the HPC space as a result of AI, although in the long run, it'll be a good thing. But in the short run, it's a huge cost driver. There's, the vendors moving away from the traditional higher precisions that we, prefer to use in HPC. It's going to be awfully hard to solve differential equations at 6 bits or less. As long as all your numbers fit between 0 and 63, you're in great shape, which is not great for the astronomers. But so there's this turn from the vendor space away from what is traditionally HPC strengths, although It means there's bigger investments in things HPC's always needed, like networks and memory latency and memory bandwidth and power efficiency. But at the same time, if we lose the precision and we lose a lot of the people, and there's a proliferation of AI algorithms for scientific computing that can replace some of the stuff we do. I was reading about one this morning that's a differential equation solver. But there's no way to verify that stuff. So it sort of undermines a lot of the V&V work done in getting people to trust HPC in the first place. So I think, there's a real danger in that they are so similar in terms of the work we do, and we're undoubtedly going to use AI in science, but that HPC as a distinct thing could disappear. And I think that's the big sort of existential threat this year. I think the under-recognized one perhaps is, whereas we have huge opportunities to make use of these devices, right? And there is stuff we can do in lower precision with GPUs. But actually exploiting all that, right? Having to essentially reinvent the field to exploit AI hardware the way we once did 30 years ago around exploiting commodity hardware instead of custom-built HPC processors, is a huge challenge and opportunity. That I think people sort of underestimate. I think the other piece of that is how complicated adapting the software stack is, right? And say, oh, we'll just port this to use a Cerebus chip. There's a million lines of very old and mostly really bad code behind these things, but it is, gone through a fair amount of community verification. So I'm concerned that we'll say, oh, just write a new code. And that's, even with the help of an AI, it's you may be able to get a code working, but then you have the 30 years of getting people to believe it works. And that's going to be a huge challenge as we start saying, let's use GPUs or TPUs or any of a number of other technologies to do HPC work.
Awesome. Thank you for those answers. It was really insightful, your top challenge there about how much pressure the success of AI is putting on traditional HPC centers and staffing and things like that. And definitely seeing that as well, but I'm glad you shined a light on that. Sadaf, how about you? What is your top challenge facing the HPC community in 2025? And what do you think is an unrecognized challenge that everybody needs to be aware of?
Yeah, so we are in a rather interesting situation at the Bristol Center for Supercomputing because we were funded to build an AI research resource as the first system. I mean, it's kind of a second system at the HPC. So the focus is on AI. However, I completely agree with what Dan said about these pressures because these are being felt across board for various reasons. So I mean, I would take Happy's approach, and I will answer based on where I'm based and anchored in, and the more kind of a perspective from the UK or Bristol, so to speak. So the main challenge I see now, and having been involved in building supercomputing for HPC or simulation-oriented applications for a long time, is it is just so difficult to, I mean, it's sustainability, I will call it in some sense. It's just so difficult now to estimate what will be the TCO of your next system, whether your data center would be fit enough to bring the next piece of kit for power, cooling, and all the rest of it. Software stacks are mentioned earlier. And on the plus side, there is some approach for standardization, but things are happening so quickly. So a place like UK, where it's not a very big country, it's not a very rich country. I know it's just recorded. I'm saying they have not been investing in HPC for a long time. So this really, and there is a people aspect to all of this thing, which I think Dan, you also alluded to. How do we sustain this rapid change of staffing? On the plus side, when we started hiring for Bricks, we said we will just hire people who know full stack development. So it's forcing us, and I'm kind of partially answering your second question on opportunity. So it's sustainability in all dimensions, from investment, from operation, from people, from codes. This is just, you could have, I mean, it's not that we had crystal ball 5 or 10 years ago when we used to build supercomputing system. Now it just changes so quickly. And it's really difficult to plan for budget, people, all the rest operation thing. So so this is kind of one of the things I think a lot about, reflecting on my previous, like all of you. I don't think there is an easy answer in the research government, like taxpayer funded research computing area. It's really, really very difficult, and all the other pressures are out there. The unrecognized challenge, and I would say is, so we are leveraging cloud native technologies in different parts of software stack, and we will talk about it. I feel like it's cybersecurity. So I should say a little bit what Bristol has been doing for sustainability, including the environmental sustainability, and on the cybersecurity side of things, maybe later on. The reason I bring it is with AI, there is an AI safety security aspect as well. And one of the main mission for Isabard AI is to do that. However, with the software stacks and very rapidly changing software and the reputational and just the public trust and faith, I feel like we are in sort of an uncharted territory when it comes to operating a classical HPC simulation ecosystem where access models and other things were sort of known, versus we are in an environment where people bring as a code data as part of the AI packages. So I think this is probably one of the things. So I think later on we can say what we are doing to sort of address that as we go along. To me, these are the two top challenges which I thought were always there. It's not that cybersecurity was not a challenge before, it just became really profound now and very difficult to manage going forward.
All right. And Happy, what about your perspective from the African continent? What do you see as the top challenge in HPC, and maybe an under-recognized challenge that you want everybody on this session to be aware of?
Yeah, look, I think in terms of the challenges, what Dan and Saraf has already touched on, it's the whole issue of investment. Looking at the demand that we see that's coming from non-traditional HPC users, and how are we going to meet this with the architectural challenges and changes, and also now we have to look at what's going to happen in terms of what has already been invested from your traditional HPC, where we were solving differential equations. A lot has been put there. What's going to happen to the code? I think that's one of the things that is there. And from the African perspective on that, it also brings this part where as a national facility, you are expected to provide these services to a broad range of users. Then that really makes it very difficult. We still have got our traditional HPC, we've got this new entrance, and you don't have a big budget. How do you make sure that you can be able to support all this community all at a go? I think that's one of the biggest challenges that I can put. What it is also not recognized is the whole issue of generative AI, where people have got sovereign AI. They thinking about sovereign AI. So there is also that sort of challenge. And when we look at sovereign AI, it's a whole lot of issues that we have to deal with. And the fears are real, which means that you have to invest in infrastructure, you have to be able to invest in your verification of the models, and how do we make sure that we train the models across different regions. And yeah, so I think that's one of the challenges that we have to think of as we bring in AI and look at how do we alleviate those fears from people who are thinking we need to have sovereign AI.
So a couple of interesting thoughts about all three of your responses. Each of you either directly or indirectly brought up the funding issue, the money issue, or I should say money issues in general. Enough funding for broader missions, enough funding for growing user communities, growing, if you will, users and customer types doing these kinds of things, enough funding to sustain and grow these systems and to embrace these larger workloads and more diverse workloads, but also the pressures in public sector put on by private sector, putting such a priority on hiring and things as well. So you brought those kinds of things up. Also in your HPC answers, all of you brought up AI. So I'm going to ask for a short addition answer in my next question, which is specific to AI. What is the greatest challenge you're seeing right now that this audience should be aware of, whether they're public or private sector? What is the greatest challenge you're seeing in scaling up these large and using these large AI models now? And Sadaf, I'm going to start with you on this one.
So what we are seeing, and I can be really concrete here. So when Isambard AI was announced, it was announced almost together with another initiative by the UK government called the AI Safety Institute. And the mission of AI safety is partly what Happy mentioned, sovereign AI, but really looking at the trust, the safety, and these aspects, and then rebuilding and reconstructing those models. So if I put now my classic HPC hat on, computing hat on, the thing I struggle with is the way people would like to bring in the code and data containers as part of one thing, because data is the way I used to distinguish, applications from data in classic HPC, it's just completely different in the AI community. And that puts a lot of pressure on both in terms of how do we do data transfer, data management, data orchestration, sharing, safety, security, because these are the pressures on one side. And on the other side, you have this demand from classic HPC systems to support up-to-date software stack containers, which are not that much standardized. Like, just to pick up one example, we have worked with MPI for ages, or at least I feel like. And now we have nickels and rickles and this binding and this code, and it's just, and then, and we thought life is really too easy, so we chose ARM-based systems. So, and I thought it was really easy. So I used ARM with the Slingshot, which is another network. So it just sort of compounds these things where you need to provide very high level abstraction, but also with high performance all the time for a diverse set of people. And some of that, we looked at it, 70% of our Isambard AI users have never been to an HPC system. They came from public cloud or similar environments. So their expectations are quite different. So this is kind of what I said, the whole pipeline of software stack management as well as data flow management and storage is really making us rethink the way things were done before, and how do we do it with again the limited resources and investments we have made already. So I'm really excited also in this regard. I think this is helping us to rethink the things which we used to do before in a different way. It is bringing some challenges but also bringing some opportunities the same way AI is bringing to a HPC workflows. So I'm excited about these challenges, and to keep my team excited, I said, look, if everything would be solved, that you would not have a job. So, but these are really, really top challenging problems. It really encapsulates both the compute stack and the data and storage and identity and access management stack of our system. So we really have to rethink everything while operating these systems, which is a huge, huge challenge.
Thanks, Sadaf. Happy, I'm going to go to you next. What do you see as the top AI-specific challenge facing these large-scale HPC centers? Be they public or private, what is the top challenge?
Look, I think the first one really, the architectures which are there, and you would know that we have got the huge requirement, and at the moment, the architectures which are there, the GPUs, we know they have got quite a lot of support, software ecosystem. There are some alternatives, but you do not really have got that much of productivity out of that. So they're still at the starting stage. So this is where we have to make decisions, and I believe if we can be able to put a lot of effort, improve all the alternatives to make sure that there's really good competition, it can help. But at the moment, we have got a real big problem with the architecture limitation that we can choose from. And if we have to do any other thing, we have to make big investment in making sure that alternative accelerators really work. The other thing for us is we have got mainly from the HPC community, people who are more coming from x86 platforms that have been doing that. And we have got really a huge requirement, especially from AI, from the large language models. As you know, just in South Africa, we've got 11 official languages. So AI, those are the people who would like to really build on the LLMs. And how do we meet that demand from the LLMs and your traditional HPC? So that's one big challenge that we are facing in providing the right platforms for these two different communities.
All right. And Dan, how about you close this one out? What is the top AI specific challenge you see facing public and private organizations and users worldwide?
Yeah, I think, well, there's a whole lot of challenges, and Sadaf and Happy listed some of them. I think I would roll up about half a dozen of them and put them in the broad category of return on investment. I think is going to be the big challenge for this year. And you mentioned all the cost things we said in the first thing. We've had almost the opposite effect in AI, and that my sense for this last year is that if you're working in the AI space, cost has been irrelevant, right? It's what can I deliver? How quickly can I get to the next biggest model? And we'll figure out how to pay for it later, right? And whereas, I've spent 30 years struggling to get a couple $100 million for an AI system. For an HPC system, there's at least 15 entities I know of that spent over $1 billion on AI infrastructure last year, and some spent tens of billions on AI infrastructure, the top 2 or 3 last year. And I just have this feeling that at some point, CFOs are going to say, hey, remember that $1 billion I spent on AI infrastructure last year? What's my ROI on that at this point, right? And while the breakthroughs in AI research have been truly astounding, right? And I don't want to understate this in any way, right? There's amazing things going on, and scale has had an incredibly important impact on that, right? I mean, if you look at most of the AI we're doing was theorized in the late 50s and early 60s, and there just wasn't computation to do it, right? And as the computational scale has enabled it, suddenly all of these old approaches seem much more relevant than they were. And it's been incredible, but the commercial revenue from that may not come nearly as quickly, right? There's only so many $1 trillion we can get out of chatbots in the near future, because it is new and it is evolving quickly, and there's a lot left to happen. And it's just not sustainable to keep this, cost irrelevant approach moving forward. As an example, the nuclear industry is currently being driven by AI, right? Nuclear power plants. The highest returning stock in the S&P 500 in 2024 was a utility company, mainly around their ability to build out power for data centers. And they outperformed NVIDIA, which is hard to do in the last year as they, minted trillions of dollars. So, and the challenge, I think, is, as well, I was reading Ray Kurzweil's latest book, and he said from 1959 to 2023, the amount of operations you can buy for $1 in that period increased by 1.6 trillion. Right, so we can do 1 trillion times more for $1 than we could 60 years ago, 65 years ago. That next trillion is going to be kind of expensive, right? The biggest AI models, the computation to train them has been doubling every 5 months, but we're sort of flat on the Moore's law aspect of that now, right? So if it keeps doubling every 5 months and it already costs, say, $10 million in electricity to train a big model, it's going to be 40 million by the end of the year with 2 more doublings, right? And because we're not going to see hardware performance go up that much this year, right? And we're not going to see much smaller transistors in the near future, right? Steadily incremental improvements, but that I don't see 1.6 trillion necessarily in the next 65 years using conventional technologies. So so I think at some point we're going to have to step back and do a lot of the work we've done in HPC, which is to focus a little bit on efficiency here. And I think there's potential to get a couple of orders of magnitude in efficiency. We're seeing already exploit lower precision, right? That's one way we're getting a lot more efficiency. And there's probably some things left to do there, but there's, not compute so many things that we know the answer to is 0. We compute an awful lot of zeros for billions of dollars right now in AI. If we computed less zeros, that would probably be useful. So use, sparse matrix type algorithms to make things better and just generally improve the software stack, as well as the kind of hardware that we use and the better accelerators. I think there's probably an order of magnitude in each of those things coming up. So, if we're going to get another trillion, and if scale really matters to doing the bigger models, we're going to have to focus on efficiency moving forward. But I think the short term is when people say, so I've spent $1 billion on AI, what did I get for it? And that, I think, will be the big challenge this year. Mm-hmm.
All right. I have so many more questions, as you know, that I would love to ask each of you, but we're starting to get some questions from the community in as well. So I'm going to ask just 2 more and ask for relatively short answers on these so we can move to some audience questions. One of them will be easy for a short answer, but the first one may not. I'm going to ask you to list, what are your top 2 to 3 recommendations that you have for customers, end user sites, and also professionals? You can mix these recommendations as you wish. How do you recommend our audience, whether they're interested in their own careers or their organization's future? What are your top recommendations right now? And in fact, one of the questions sort of relates to this that's already been submitted. So when you talk to people, what do you recommend that their company or center do? And what do you recommend that they learn and do? And Happy, I'm going to start with you on this one.
Look, I think the main thing is we have seen that starting from high performance computing, it has been one of the things that one had to put a lot of effort to be able to advance in your career. But at the moment, we have to look at these changes now where we're bringing in other novel technologies and applications. So I think it's the basis of HPC is still very important, and how this evolves, that's that adjustment that we will have to do. So we have to get into that. The software is no longer like your general way of writing software. We have got new advancements, so we really have to adapt with what is coming. But let us not forget the basics, because if you go jumping into the new evolving applications without the right basics, then we might be in trouble. Yeah.
All right. Sadaf, I'm going to go to you next on this one.
Okay. So I think the first one is this one, community. So for those of you who joined this call, you did the right thing. It's not just because I'm here. I think I would encourage you to join the other topics, because this is what I will tell you. Like, if I'm 30 years. What is the main thing you should do is, identify the community, be part of the communities, whether it's this one or the other one. So at an individual level, I think that's probably one of the important things I would recommend. And I would attach mentoring as part of it, whether you're at the senior level or starting up your firm. So that's kind of individual. For a company, so now having started like a data center from like almost zero and nothing, it's people. You need to have the right leadership, the right trust team, and then build the team in a way, because you could have all the money in the world, but if you do not have the the correct leadership and the team to execute on that, it may work, who knows. But that's the other thing I would. So if you are in a company and you have to do something new or starting, make sure there is the team, there is trust, there is commitment, and you give them charge. And I'm really appreciative of the UK government. They trusted us to kind of build this infrastructure like that. The third thing is maybe more specific to where I am coming from, like a research computing government-funded institution. No matter what anyone tells you, focus on public good. So when building Isambard AI, we had a lot of pressure on go and buy a bunch of DGXs. I have nothing against DGXs, but when we looked at the TCOs and other things, as Stan mentioned, and we looked at, UK is a small country. We have a data center is in a car park in a modular data center. So no matter what anyone tells you, try to really look for, what is the mission you are serving. And because right now we are overloaded with information. So really anchor yourself. What are your core mission and core principles of what you do? And then make a decision based on that. So these are the three recommendations. I know they are not very technical. I'm not giving you a piece of technology advice and other things, but we are here, or I feel like we are here in this position because of these three things. And
I really appreciated both you and Happy addressing the fundamentals, which include, people, teaching people the fundamentals, taking care, developing people, et cetera, especially when things are moving this rapidly. And you're right, that's one of the reasons we're creating this community. Dan, you want to close this one out?
Sure. And I'll just do two because we've already heard some great ones. But I think for organizations, this is a pet peeve that you will understand from me, Jay. One is pay attention to how you run your infrastructure. And this applies whether you're doing on-prem or cloud or anything else. But, along with this, and, in the HPC world, we've spent a lot of time figuring out what's the best way to manage and grind every bit of efficiency out of systems. And I increasingly see particularly non-tech companies, but big financials, spend tens of millions of dollars on AI infrastructure and basically say, drop a pile of DGX boxes there and not have a scheduler or any way to arbitrate user access. And people just log in and run stuff at random. And if they don't log in, it just sits idle because it's allocated to one group, but another group can't get to it while it's allocated to that group. And there's so many lessons to learn about how to run infrastructure efficiently and things that we've already solved in HPC. So, if you're dropping $100 million on HPC or AI related infrastructure, maybe spend $1 million on some people who know how to run it and some tools to do it. 1% of that investment would be useful. So I think that for organizations, because I just can't tell you how many places I've seen do it so wrong. And I guess if you're selling cloud time, it's a good thing if people really underutilize it badly because you're selling by the hour. But if you're an organization, you want to make that investment run well, right? So whether it's in the cloud or on-prem, how you manage it makes a huge difference. And from the career side, just to echo some of what Sadaf and Happy were saying, I think it's really important that you're sort of aware of what's changing, but that you're not chasing the trends because they do come and go. So AI is the hot thing now, but again, if you want to run AI infrastructure, if you've been in HPC the last 20 years, you know everything you need to know to run AI infrastructure. And I remember an argument with a CS faculty member here at UT 15 years ago that, parallel computing was a dead end, right? And now all the large AI frameworks use MPI at their core or use Nickel underneath it, right? And message passing is the key. Doing this stuff and scaling these out. It's $1 trillion industry, right? So they were very wrong. But you sort of don't blatantly stumble into something that technology is about to make completely irrelevant. But I know even in computer science, there's this, well, AI is going to write the code now, so we don't need computer scientists. That's sort of ridiculous at this point, right? First of all, those AI models break every day and somebody has to fix them. And two, somebody has to come up with the architectures, which is basically computer science for those models that will write the code, which involves other kinds of code. So, if you think you love coding, go do coding and don't worry about whether or not be aware of how to do it better with AI. But don't change what you want to do just to chase the money, because things keep changing. So.
I haven't asked a quantum question yet, and I had a couple or even 3, I think, in the list that I sent you in advance. I'm just going to ask one of them here to close out, and I'm going to ask the most basic one. A lot of quantum computing announcements in 2024. Almost all of them included the word revolutionary, game-changing, breakthrough, transformational, or some other adjective of that scale. And yet some of them actually were really revolutionary, including the error correction technique that Google announced in 4Q. There were a few others as well. Do these the real announcements, the ones of real achievements in this space, not just scaling qubits up, but running longer times, handling errors better, do they give you some confidence that your centers may be very active in hybrid classical quantum before the end of this decade? The discussion a few years ago, there were still a reasonable number of people who thought that quantum computing may never become mainstream. A year ago, maybe, but 5 to 10 years. Lately, I'm hearing more, yeah, probably within 5. So a lot more people are confident about the decade, at least. How do you 3 feel about that and your communities and your center's ability to deploy hybrid classical quantum by the end of the decade? Are you starting your evaluations now? Are you expecting that may really be a viable HPC solution type, a hybrid classical quantum system before the end of the decade for your users? Dan, you want to start?
Sure. And I will say, these long-term predictions are always dangerous because 5 years ago, we were barely talking about AI in terms of forecasting the centers, right? So until it sort of captured the public imagination with ChatGPT. So but I think you actually summarized the way I feel about it pretty accurately in your intro, in that 2 years ago, I was sort of 80-20 quantum would work ever in favor of ever, but still thinking there was a significant possibility we wouldn't get there. I think in particular, the last year's progress on error correction has, with virtual qubits and various other things, 800x improvements in error correction rates is the kind of curve we need to be on to make this useful. So I do think, having some form of practical accelerator in 5 to 7 years is a pretty reasonable target at this point. And I believe it's going to happen. I'm more like 95-5 than 80-20. I think on whether it will be useful in at least some cases in computing. I think from the center perspective, in the very short term, I still can't buy a machine that does most of what my users want to do right now. And that's really going to drive our near-term investments. And I also can't seem to keep people who do the algorithms because they go work for cloud vendors. I'm 0 for 3 on that in the last 7 years. So my last 3 quantum leads have left for the cloud. So, but I am relatively optimistic we'll be investing in that timeline. I'd say we're still in sort of a wait and see mode as to when it hits that. At least for the way we operate, when are users going to embrace it to solve the problems they need to solve other than our quantum computing researchers? So I certainly think we'll see more. I think 5 to 7 years is a good timeline. The vendors are all saying, that the size systems I see as useful are like 2029. So I assume that means 2031. But yeah, so somewhere at the end of the decade is about right, I think.
Happy. How about the perspective in Africa on quantum computing?
Look, I think from the lessons that we learned, let's look at, for an example, the GPUs when they came. We never thought they will be so pervasive. And only people who started early, prepared themselves, started benefiting because you had the right skills to be able to program the GPUs. You had applications which were designed well to take advantage of the GPUs. So I think at this stage, we also have to look at this. Quantum might be too far for some people. Some people they're already in there, they start seeing benefits. So one has to think about what will happen if tomorrow we wake up and classical computers are swept out of our feet. What are we going to do if we are not prepared? So I think the investment now in terms of getting the right skills to program quantum computers, it's now start working on that. From South Africa point of view, we already have got some of the scientists who, let's say, for an example, quantum chemistry people, start exploring, seeing some benefits. So we have to start building on that. And of course, the access in terms of investment, that's where we see cloud providers being very helpful, because the justification of the investment into a quantum computer might be a little bit difficult to justify at this stage. And having access through your cloud providers, that's the best way to do. So build the skills, start preparing applications, and collaborate with the people who have got the technologies.
All right. Thank you for your answers to that. I'm going to start with some audience questions. We probably just have time for a couple, and then I'm going to share all of the questions with you. And if you have time to contribute an answer after this session, great. If not, I totally understand. You'll even be able to record those answers and send them, and we'll transcribe them if you want. But I'll pick a couple here now. The one that got voted up the most is Deepak Suresh asked, what are the most in-demand roles in the HPC world right now? I'll open this up to any of you to answer this. And maybe it's different for your regions.
Yeah, and I'll start. Good system administrators remain, and I saw Deepak's list of questions in the Q&A there. Sounds like he has a background in a lot of this stuff. Systems people are the hardest to find, right? I probably hire more in other fields, but I get much wider pools of applicants, whereas for good systems people, they're almost impossible to find. So, that strong Linux and enterprise background you have with, I think the one thing to add in there is some, dealing with the interconnects and the networking and parallel file systems. But yeah, I mean, we hire a ton of people doing applications. We increasingly hire a ton of people doing AI, everything from scaling frameworks to parameter tuning to, data curation around that. But, when I look for an application support person, I might get 30 good applicants. And when I look for a sysadmin, I get like maybe one. So.
All right. What's it like in your area, Sadaf? What's the most in-demand HPC role?
We are hiring, although the salaries in the UK public sector are not that exciting. So we twisted around our roles. We posted every role as a full stack developer, because I always say it's like a Fortran moment for system admin, like it was for applications. So if you are going after a smaller pool, you just train them. And being part of a university, we can probably train people. So I would say that, yes, for me, I always structured with identity and access management and cybersecurity roles. So they are pretty much in demand, and you can't even afford to hire them in most cases. For the other ones, as maybe Dan and I can talk offline how he can use our approach. Or my charm to hire.
I've got system administrators, I've got cybersecurity professionals. Happy. What about in Africa? What's the most in-demand HPC oriented role?
Yeah, look, I think it's the same with what Sadaf and Dan shared. Definitely from the systems point of view, parallel file system, big challenge, and security.
All right. I want to thank you all for your time. Again, we can't get to all the questions, but I'm going to send you all the questions afterward. And if you have time, we'll get your answers and we'll make them available to all of our attendees.